Okay, a box of slices of oranges slides from rest. We're being very specific. Frictionless. I like frictionless from a height. And then friction happens. Okay. The coefficient of friction is, ooh, we got a few steps here. So we start with from rest. Awesome. Just potential. Down here we have just kinetic. And then, do we stop at the end? To rest again. They were really nice. They did not have to be that nice. To the end where energy equals 0. Okay. The whole time we're remembering that if no work is done, energy is constant. So the UG here equals the K here. So we know UG at the top equals K at the bottom. That is a fact. MGH equals 1/2 mv squared. That is a fun fact we need to keep in our brain. Also, we started with a lot of potential energy, and then it became all kinetic energy. We didn't lose one little bit. The law of conservation of energy says if no outside forces do work, the total stays the same. But then an outside force did work. Friction happened, and we lost our energy until it was nothing. We had no energy. Energy is 0. Womp womp. Because all of that was lost to the work of friction. Work of friction. So they are asking, what is the coefficient of friction? Okay, so we know friction equals mu times the normal. Do we have a mass? We have a mass. Luckily it's a flat surface, so friction equals mu mg. Also, we know that the work done to take this out, work is force times distance. So the only force doing work is friction. So work divided by the distance, that's going to equal friction. That's helpful. Also, the work done is equal to a change in energy. So however much energy we started with at the beginning, the work takes that out. So I'm saying all this to say we don't have to calculate the potential and say, let's do it. Actually, let's do it the slow way because y'all learned how to do this like a week ago. It's still new. So the potential energy is mgh. The potential energy we start with is 9 times 9.8 times a height of 3.2. So we start with some amount of potential energy. So that's 282.24 joules of energy that we start with here. 282.24 joules, which means we have 282.24 joules of kinetic energy when we start, and we used it all up, and we have no joules of energy at the end. So the work done is force times distance. The work done, it was all 282.24 joules. That's how much work they zapped out of our system. We don't know the friction force. No. Come on, Pian. We got work to do. Dang it. Okay, hopefully this works. All the work done zapped energy out of our system. That equals, you better work now. Thank goodness. That had no backup plan. Force of friction times the distance, and the distance is 19 meters. Ooh, it took a long time to bring it down. So 282.24 over 19. That's the friction force, which also equals mu times the normal. The normal is mg. So the mass is 9 and g is 9.8. Weirdly, this is one equation with one unknown. We can solve this. If we do that fraction, 19. So that's 14.85 equals mu times, what's 9 times 9.8? Times 88.2. Then we divide. I'm actually going to go grab that thing so we don't lose any decimals. I got a mu of 0.168. How many sig figs we got? Oop, 2.17. That's how to do that one.